Hello everyone, my name is Sherief Elbassuoni and I'm here with my colleague Matrix. We are here to share our traffic analysis findings for the VSIM work we conducted at the IDS or International District Station area close to downtown Seattle. So the IDS area is pretty unique because we have it's pretty busy office tower area. It has a lot of historic buildings that is around the Pioneer Square. It has soda stadiums. We have two interstates. The first one is I-5, the second one is I-90, and these two interstates are feeding traffic to the IDS area. We have a lot of transit activity around this area because King County Metro has two transit bays along 4th Avenue. And along 4th Avenue, three of our biggest transit agencies are running their service. The first one is KC Metro or King County Metro. The second one is Community Transit. And the third one is Sound Transit. And all of these transit agencies has different buses, trolley buses, diesel buses, battery buses, a lot of buses in this area. Because of the King Street station that is located at 4th and Jackson, we have a lot of beds in this area. So we have between 500 and 800 beds per crosswalk. So after I ordered the turning movement count, I looked at the report and I contacted the company like, are these numbers right? I want to verify the video. So they verified the video and I watched some of these videos. Yeah, some of these bed crossings are very busy because of the King Street station. If we zoomed in a little bit, this is our study area. Again, it's in the southeast corner of downtown Seattle. And our focus area is basically 16 signalized intersections that are represented here in the black circles, and we have 14 unsignalized intersections. The way that we included, like our main focus is 4th and Jackson, but we also included all of these side corridors like 6th Avenue, 5th, Main, because as we'll be covering later on, King County Metro is interested in some rerouting, and these reroutes are going to use 6th Avenue and other corridors. For the geometry, we have some pretty unique and interesting intersections in here. As you can see here, one of the examples is the intersection of 5th and Seattle Boulevard. It's a 5-leg intersection. Here we have the D2 ramp. It's basically a transit ramp. If you are looking at the westbound approach, we have one westbound right turn lane and two through lanes. But for the downstream, we have one westbound right, one westbound left, and the middle lane is basically a shared through right and left. So here, if you're looking at northbound 5th, it's basically one lane. For the southbound, it's two southbound left turn lanes. If you're looking at southbound right, it's a slip lane. If you're looking here at the intersection of 4th and Jackson, we have here a right turn pocket / lane because buses, this is a very heavy bus area. After that, we have a bat lane. Here we have two GP lane, another bus lane that is serving this transit area after crossing the intersection. So it will be nice to test VSIM 2020 and how VSIM 2020 is going to handle the conflict area of some of these interesting intersections. What DKS was tasked to do. So basically our main scope is covering three main topics. The first one is test the impact of all the upcoming route changes. So as I mentioned earlier on, King County Metro, Sound Transit, and Community Transit are making a lot of changes because of the D2 ramp closure. They are also changing the headways of these buses that are running along 4th Avenue. They also want to test what which reroute they should consider. Should they consider this alternative, like instead of moving along northbound of 4th, should they take this route, or should they take north and after that turn right at Seattle, then left again at 6? They are also considering adding like one more bus stop. So this bus stop at northbound 4th and Jackson is currently serving two 60-foot buses, and they would like us to consider adding a third 60-foot bus stop. So it's basically gonna be a longer bus zone. We also, part of our scope is to basically consider how we can improve the operation along 4th Avenue. So in here for the I-90 off-ramp, the current configuration is basically 2 lanes and an eastbound right turn lane. And the middle lane, it can serve the eastbound right and eastbound left. So they were asking us what is the best channelization for this off-ramp. Should we keep the middle lane as it is right now, or should we change the configuration to something else? Which is pretty interesting because all of these stuff are basically needing a lot of iterative, a lot of testing. Another example is the intersection of Seattle Boulevard and 4th Avenue. They also asked us if we can help them with this middle lane. Should we add it to the door right or to the door left? The main analysis tools we used in here are basically vSim10 for the micro simulation work, and we used vZoom 17 for the OD and static routes, and we used the dynamic traffic assignment for this work. My colleague Matt is going to cover some other slides.
So they wanted to look at some additional stuff that affected more of the GP traffic directly as well, and that was a couple turn restrictions. You can see the red dotted line paths are where the existing turns are available, but they wanted to take some of those out. So we had to account for that in the model. And then just to kind of touch on the congestion in this area, there was a lot of, it's a pretty congested area. It's just I would call it just south of downtown a little bit, downtown Seattle. So AM, PM peaks are very busy, and this area is very busy in both peaks. The inbound, so northbound on 4th Avenue, is busier in the AM peak, so the queues can extend a long ways there. It's still busy in the PM, but a lot of the PM traffic is more in the southbound direction. So we did an alternatives analysis. They had several alternatives that they wanted us to test. It was only on existing years, so that was kind of nice. We didn't have to project out any volumes or anything because they wanted to capture the impacts of doing these things right away. So existing conditions model with current traffic volumes, current traffic signal timing, transit routes created and calibrated to generate a baseline model for our comparisons. And then we had 4 other alternatives. And then transit, so in addition to what Sherief was describing, there's an existing transit tunnel that runs underneath downtown Seattle, and they wanted to move. So when we did this analysis, the streetcar or light rail, the light rail and buses were both running in the tunnel. So as part of this project, they wanted to pull all the buses out of the tunnel, and so we had to measure the impacts that would have on the surface traffic. So vZoom, used vZoom to generate the OD matrix so that we could import that into vSim. So vZoom used the T-flow fuzzy procedure sequence, and then we brought that into vSim and used DTA to generate the static routes. However, so one thing to consider with this as well is that since a lot of the modeling was dependent on how well the bus stops could perform, so it had to do with bus stop capacity. We had to use 27 vehicle types and 15 vehicle classes so that we could break up the different types of coaches in the model. So King County and the other agencies, more so King County has a mixture of 60-foot and 40-foot buses, and then they have a mixture of electric trolley and diesel buses. And for any particular route, they can have a mixture of all 4 of those things. So we need a lot of vehicle types so we could capture the stop capacity well on that. And then this one, so I hope you can all see the priority rules. So we did not program these in manually. We didn't have an intern or anybody do that for us. We decided to write a script. So that made this a little bit easier. So we wrote a script in Visual Basic, and then it generated a list of where these would be, and then we copied that into the text version of the vsim file. But essentially what these are doing is there's streetcar and trolley bus operations here. Typically in most areas there's only one set of trolley wires, so they can't actually pass each other. So the streetcar obviously can't change lanes, but the trolley buses can. So we needed to incorporate something in there that would make it so that the trolley buses couldn't pass each other. And then they couldn't pass the streetcars either. So that's, and then along with the trolley bus operations, there's lots of special operational rules that apply to them, and Sherief will cover some of those.
So as Matt mentioned, like just setting up the priority rule was pretty tricky. So these are some of the parameters we used for the priority rule. We basically wanted to make sure that trolley buses are not passing the streetcar and not the other way around. When we left everything before putting any of these priority rules, we found trolley buses are passing the streetcar. The model was running in a pretty funny way. We also have some pretty interesting special work zones because of all of these wires. So we went to the field, we collected where these wires are located, and we also set some meetings with our client, Kent County Metro. And basically we wanted to mimic basically all of these wires into our vsim model. But more importantly, we wanted to mimic the driving behavior. So we started to implement some of these reduced speed areas in our vsim model. So at some specific location, all of these trolley buses are directed and they just got used to slow down whenever they get into the intersection or they are done from going through the intersection. So we started implementing some of these reduced speed area.
And they're instructed to slow down because if they drive too fast where the wires cross, it can pop the arms off, and then they have to go back there and try to get back on because the bus stops because they don't have any power.
Yep. And there are some specific locations where they can cross each other, but these are basically like emergency location. So they are directed not to pass each other unless it's an absolute necessity. While we were working on this project, like we have some different stakeholders. So number one, the three transit agencies gave us like what are the bus routes, which corridors they are going to run into, but they didn't give us any schedule. And they asked us, can you help us with a future schedule for this one? So, okay. We were experiencing a lot of bus punching, similar to what you can see in here, like 3 buses are just arriving at the bus stop. So our goal was basically to come up with some different bus entry times, which they'll be using besides other tool as a starting point for their upcoming schedule. So we did some tweak to accommodate the stop capacity and to handle the bus punching. One of the requests is that like this is a transit corridor, whether we are talking about the East-West Jackson or the North-South 4th Avenue. So they asked us to help them with improving the bus progression along this corridor. Another stakeholder, which is SDOT, Seattle Department of Transportation, they are directing the streetcar drivers not to cross the intersection if they have a short block, similar to the situation we have in here between 2nd Avenue extension and 4th Avenue. So for this eastbound streetcar, if the streetcar can't cross this intersection, cross the short block, cross this intersection in a timely manner within the green band, the streetcar will just wait till it finds an enough gap or just wait one more cycle. So this is one more consideration we needed to take into our mind while we were either calibrating or working on improving the operation along this corridor. A third interesting request we got is basically to improve the bed progression because of the King Street station and the 500 to 800 beds at some of these bed crossings. The King County Metro and SDOT basically asked us if we can help with basically improving the bed progression. So if a bed is crossing from this side all the way to the bus stop, the northbound 4th Avenue in this corner, we basically need to improve the progression of buses without impacting the GP and without impacting the streetcar, and all of this while beds can cross all of this distance as much as possible without stopping in here. So we started building a synchro model just to balance beds. So as you can see here, beds are not just crossing like one leg of the intersection. We basically built up a bed synchro model. And we started to balance, okay, these beds are coming from here to here to here. And after a lot of field work, we balanced the synchro model. And after that, put everything, we balance it into Visa. For the lane change, based on our field work and the feedback we got from the transit agencies, south of the I-90 off-ramp, here it's basically GP lanes, but north of the off-ramp, we have a BAT lane, and after that, the GP lanes. So if a bus is stopping at this bus stop on the east side of 4th and Jackson, and the bus is heading northbound, the bus will basically keep driving on this lane, after that drive on the BAT lane, till it serves the passenger at this intersection. But if the bus is moving north without stopping at this specific bus stop, we found from our field observations that bus drivers, even if they have a BAT lane, bus drivers don't really drive on the BAT lane. They prefer to just keep driving on these GP lanes without going through all the hassle, buses, GP, and all of the congestion at this intersection. They just skip the BAT lane and keep driving north on the GP lane. So calibration of this area was done using the lane change parameters in Visa. Matt will cover a few more slides.
So, like I mentioned earlier, we calibrated it. The calibration was mostly, it was travel time based and then these other things as well. But the travel time was mostly focused on the transit since that was the best data source. And then, so also calibrate on transit volumes since there is a lot of transit here. So we incorporated, Sherief described some of the bus station, some of the bus layover areas that they had there. So we incorporated deadhead buses and we incorporated buses that were traveling to their routes and stuff like that. So, you know, we could get on just north of here, I know that like 3rd Avenue has over 100 buses per hour in each direction. So there's a lot of buses in this area. And we calibrated based on general purpose volumes and then our field observed queuing. So these are basically the alternatives we looked at. We looked at an additional bus stop near Weller Street, and then traffic signal changes, those turn restrictions that we previously described, and then transit route changes. So like I said earlier, all of our future things, we didn't have to go out into a future year. Everything was for the current year. And then we incorporated, like Sherief described, the closure of the I-90 ramp that was buses only, and then increased stop distance because it needed more capacity, and then updated traffic signals to improve congestion. So these are kind of the results. These are just some level of service results, so you can see that. AM functions fairly well on that northern part of the area, whereas the southern part is just pretty bad no matter what. And then the PM is just a little bit busier in all portions of it. But I think one of the main things that we got out of this is that the transit agency, King County, could incorporate a lot of these changes without having significant impact to traffic. So what did VSIM and VZoom help us to? So VSIM allowed us to model complex transit operations on a congested network of intersections, and then the results informed all the agencies involved of what they wanted to do and how that would impact the area. And then what I liked the most is that it let them have very targeted solutions to that. So instead of maybe going overboard on a huge fix, trying to change something on a big scale, they're able to say, you know what, if we just change the length of this bus zone, or if we move it to a far side or a near side stop, it'll do what we want. So it allowed us to do very targeted improvements.
Yeah. Besides this transit benefits Matt talked about, we're also able to provide Kent County Metro and SDOT with some of the channelization changes they can do at the I-90 off-ramp and the intersection of 4th and Seattle Boulevard, 5th and Seattle Boulevard. So this is one of the changes we proposed. Instead of like 2 lanes and a right turn pocket, right now this is the configuration they went and moved forward with. Basically, the right turn is going to be like a right turn lane instead of a pocket, and the same right turn is going to be as a transit lane. So only transit are allowed to use this lane if they are turning for the eastbound left turn movement. The other 2 movements are basically eastbound left turn. I'm happy we are on time. It's time for questions. Can stop the stopwatch.
6 minutes.
Yeah.
So I'm not a modeler, and I'm just curious to know, like, why do you need to build in or the catenary wires into the model?
Well, we didn't have to build it in, but we had to capture what it meant for the transit. So like we said, it had a big impact on how buses are able to proceed because they couldn't necessarily pass each other. And then everywhere where they cross, buses are instructed to slow down. So we had to go out and observe where that happens because the buses are supposed to slow down going into those.
But in the model, can you set the
Mod-
parameters on speed?
Yeah, it's basically reduced speed area.
Yeah.
So
Yep.
whenever, and we assign this speed, reduced speed area for all of these buses.
Yeah.
Whenever we have crossing wires, we basically started to place these reduced speed areas.
They weren't necessarily in the same place at every intersection. So like this is an example where the crossing was in that area, and then other places they'd move around.
Do you think the lane change distributions by vehicle type could have been a way that you could have combated the lane changes?
Yeah, I think that would be really helpful.
Yeah.
Because we had to make decisions because we would sit down with the client, they'd watch it with us, and they would say, we want the buses to change lanes right here. And we'd say, okay, we can do that. But what we ended up having to do because of that is some of the lane changes we had to make shorter because they wanted them to cross in a certain place and then not change that. So we had to make some of them shorter, some of them longer, and the impacts to the GP traffic GP routing was affected by that.
Yeah, and besides what Matt mentioned, we also started to redirect some of our transit lines using like some specific connector. So if we see in the field that these specific bus lines are not using this lane, we started to force them to change lane in this area, just to make them match what they are doing in the field. Any other questions?
Looks like that's it.
Thank you.